Hello, in this video I will discuss algorithm to find lowest common ancestor for given pair of nodes present in the tree. Let's take a couple of examples to understand the problem and what is expected out of it. Let's take a simple binary tree. Let 4 and 5 be the given pair of node for which we have to find lowest common ancestor. In the tree, ancestors of 4 are 2 and 1, which is same for 5 since both 4 and 5 are children of 2. Out of 2 and 1, 2 is lowest and is our lowest common ancestor for 4 and 5. Let's consider a couple of more cases to understand the question properly. Let's have same tree, but in this case we will have two different nodes, which is 4 and 6, for which we have to calculate lowest common ancestor. Ancestor for 4 is 2 and 1 as in previous case, and ancestor for 6 is 3 and 1. We can see that 1 is the only common ancestor for both 4 and 6. Since there is only one common ancestor in this case, we will consider that to be the lowest one also. Let's consider one more case in which given pair of node are 2 and 4. In this case, ancestor for 4 is 2 and 1, and for 2 is just 1. 4 lies in the subtree of 2, hence 2 is going to be our lowest common ancestor. Now I will outline the algorithm for calculating lowest common ancestor. First we will check for the terminal condition, whether the current node is null or not. Then we will compare both the given nodes values to the current node value. In case there is a match, then we will not be traversing nodes below the current node and we will return current node as probable LCA. Reason being is, if the given non-matching node lies in the subtrees below the current node, then current node is lowest common ancestor, as we have seen in example 3. If none of the given node matches the current node value, then we will go ahead and traverse left subtree and right subtree. If we have valid node returned from both left subtree and right subtree, then current node is the lowest common ancestor. Otherwise, we will return null or the valid node from either of the subtrees. Let us visualize our algorithm with the examples we have already seen in the beginning. We have to find lowest common ancestor for 4 and 5. We'll start our recursion from the root node, which is 1. I will use green arrow to show that I am going to visit a child, and I will use blue arrow to show that I am returning from a child node to a parent node. If we are returning some valid value, then I will write that value in the square box, and if we are returning null, I won't be writing anything. 1 doesn't matches to any of the given node, so we'll go and traverse the left child node, which is 2. Again, 2 is not one of the given nodes, so we'll go and traverse left child, which is 4. Now 4 is one of the given nodes for which we have to find lowest common ancestor, so we will return 4. We are back to node 2 after traversing the left child, and now we'll go ahead and traverse the right child. 5 is also one of the given nodes for which we have to find lowest common ancestor, so we'll go ahead and return 5. We are back to node 2 after traversing both left and right child. Both left child traversal and right child traversal give us valid nodes, so in this case we just found our lowest common ancestor, which is 2. We are back to our root node after traversing left subtree. Now we'll go ahead and traverse the right subtree. From root node, we move on to the right child, which is 3. At 3, we will first visit the left child, which is 6. Since 6 is a leaf child, we will return back to the node 3, and from node 3 we will now go ahead and visit the right child, which is 7, and from 7 we will move back to 3, and from 3 we move back to our root node. At root node, a left child is returning a valid node, which is 2, and the right child is returning null. So we are going to return 2 as our lowest common ancestor from the root node. Let's visualize the algorithm for finding lowest common ancestor for 4 and 6. We'll start with root node 1 and we'll visit first left child 2, as 1 is not one of the given nodes. At node 2 we will first visit the left child, which is 4. At node 4 we see that it is one of our given nodes, so we will return 4. We are back to node 2 after visiting the left child. Now we'll go ahead and visit the right child, which is 5. 5 is a leaf node and also it is not one of the given nodes, so we'll return null from this place. We are back to node 2 after visiting both left child and right child. Since left child have returned a valid node, which is 4, we will be returning 4 from this place. It's time to visit right child of the root node. At node 3, we'll first visit the left child, which is 6. 6 is one of our given nodes, so we will return a valid node. We are back to node 3 and now we will visit our right child, which is 7. Since 7 is not one of the given nodes, so we will go ahead and return null, as 7 happens to be the leaf child. We are at node 3 after visiting both left and right child. Here left child have returned a valid node, which is 6, and right child have returned null, so we will return a valid node, which is 6 from node 3. At root node we have valid nodes from both left child and right child, so we will be returning root node as our lowest common ancestor. This is our last example to visualize. We have 2 and 4 as our given node, for which we have to find lowest common ancestor. We'll start with root node 1 by visiting its first child, which is 2. 2 is one of the given node, so we won't be visiting any subtrees below 2 and will be returning current node as valid node. From root node we move on to the right child, which is 3. At 3 we will first visit the left child, which is 6. Since 6 is a leaf child, we will return back to the node 3, and from node 3 we will now go ahead and visit the right child, which is 7, and from 7 we will move back to 3, and from 3 we move back to our root node. At root node we have a valid node from left child and right child is returning null, so we will be returning the valid node, which is 2, as our lowest common ancestor. Let's quickly implement this algorithm in C++. Checking terminal condition whether the current node is null or not. If it's null, then we won't be proceeding further and returning from this place. Checking whether the current node is one of the given nodes. If current node is one of the given nodes, then we will be returning it as a valid node and won't be visiting any of the subtrees below the current node. Visiting the left child and the right child of the current node in case when current node is not one of the given nodes. If we get valid node from both left child and right child, then current node is going to be our lowest common ancestor for the given nodes. If one of the childs have returned valid node, then we will return that valid node. In case both of the childs have returned null, then we will be returning null from this phase. Let's quickly write test cases to validate the examples which we have previously discussed. We'll quickly run the test cases. Test case is passing. In this video, we discussed finding lowest common ancestor for a pair of nodes in the tree. If you want me to discuss any particular algorithm, please write it in the comments below. I will try to put up a new video for that.